I want you to go to page 16 on the first booklet, and I will give you the second one already because we're gonna start that second booklet right after this. So go to page 16, and you need to add to that second example. I probably will not do the second example. I'll just give you the key, the answer. But that second example doesn't work unless you have a side, right? So some of that side length didn't make it on there. So it's 7,201 miles if you want to add that already. On page 16, that second triangle. Add that. Just hope to put part 2 on it right away. Trig part 2. What? I just grabbed it. I saw yellow and I was like, my favorite color. Get it. Salmon, whatever color. What's this central? Yeah. Yeah. Go ahead. Everybody got one? Part 2, Trig, put it on there right away so you're not mixing them up. Part 2 Trig. Right. Emerald, would you mind turning off the lights? So today is going to be a bit, maybe extensive, maybe too much information for some of you. But I need to start word problems at this point. And you will see quite a bit of sine law today, but don't forget about cosine law, right? Don't forget about it. So I'm going to go back up to this one. And so I want to do at least one of these. Right triangles are still going to appear. They're going to be quite frequent, and I need you to be comfortable with that, okay? So here we are, that first example here. So it's asking to solve for the indicated side. So the idea is this is x here and y is here, right? Looking at this triangle, I always like to put down letters for the angles if there aren't any provided. So I go A, B, C, and I will put a letter right here at this intersection, right? So A, B, C, and then D there. So if I want to refer to, right, if I split this angle, I can split it, right? And know which one I'm referring to. So here we go. The key here is how do I start? You should see that this dashed line is the height, and then it's splitting my triangle into two, not same triangles, but it's splitting it into triangles, right? So which one should you start, left or right? Left, right? Left, right? That's doesn't work very well, but it's the left side because there's more information. If you just look at that one, you have that side given there, right? So it makes sense to start with the left-hand side there, okay? And I want to say this: you will from time to time look at the triangle and ask yourself, why isn't Mr. Dirksen solving it this way? Because I'm seeing something here. Why is Mr. Dirksen going this way? Because that's just the nature of these problems. There's more than one way to solve. So don't be shy to try your own way. As long as you get the same answer, we're doing okay, right? So if you see a different way, by all means, go give it a try, right? But normally the reason I do it my way is because I've seen issues trying it a different way, and I want you to avoid having those problems. Okay, here we go. So I'm going to start with number 1 here, and I will draw it out here for us. So Let's just do that real quick. Doesn't take long, and it gives you a very good perspective as to what's happening. Copy in what you know. There's a 90 here. And by the way, if there's a 90 on this side, there's a 90 on the other side. And this is 79.2. Okay? 79.2. So, and obviously they're asking me to solve for this side right here. This is the unknown here. Okay? So you should see a pair right there. Okay? So sine of 90 over 79.2. Anybody remember what sine of 90 is equal to? Uno, right? 1. So instead of saying uno next time we play cards, you say sine of 90, right? And then nobody's going to get it, but you will sound smart. Anyways, to find this side, I need this angle. Okay? Because sine of 32 will get you this. You don't want that. You want this. So you have 2 angles already. Find the third one. I'm just going to do that work on the side. Well, maybe here. Angle B in this case. Angle B, that angle will be 90 minus 32. Does that make sense that I just go 90 minus 32? Because this 90 is already taking away from 180, so I'm left with 90 minus 32. So I'm left with 58 degrees. Okay, this is now 58 right in there. So sine of 58 over x. Okay. Again, you start figuring stuff out like, oh, I have the 90, I have the 32, 180 minus 90 minus 32 gives you that one up there, right? So this is important. And then just start solving, right? 79.2 times sine of 58. I will still write down sine of 90, okay? I will still go through the process, but I will not type that into my calculator when I do it, okay? When you do that, you get, let me check my key here, 6717. But I will double check because 6717, there it is. And that is in yards, okay? So you just figured out that one missing side, probably 2 marks associated with that, okay? And now I have to find that second triangle because we have so much room, right? Why don't we do that here? Second triangle, I draw that out. This is a 90 as well. Got the 49 is in this corner. C, D, B. And that's all you know, really. Okay, you just have that. You have those 2 angles. Why don't we go ahead and find that angle up here right away? That's 90 minus 49. That's 41 degrees. Because there's a big chance that I will need that 41. Okay, to find this side that I'm looking for, which is y. Okay, so what do I do there? What can I do? I only have, I don't really have much that I can do there because I have no sides whatsoever. 3 angles, no sides. Anybody care to answer this one? Okay, so you're saying look at the big triangle, right? Find this whole angle here, and then we would be able to find the whole base here and then just subtract x from that base to give you that leftover. Yes, that is one way to do it. But there's another, I don't know if you remember me. You should remember. How do you find the height of this triangle, which would coincidentally be this side right here? Let's call this h, okay, for height. The height will be what? 79.2, like this side right here, times sine of 32. So that gives you, if you go at 79.2 times sine of 32, I'm looking at my key right here, and that's 41.97 yards. Okay, which I'm just going to underline, which is because it's important to me. I now know that this is 41.97. Okay, and now you have a pair. I don't know if you noticed that. Sine of 49 over 41.97 is equal to, you have to be careful, you want y, so I'm going to find sine of, I'm going to use sine of 41 degrees over y. And then it's just 41.97, right? This times that, divided by sine of 49. So Coda, your answer was very good, okay? It would have worked just fine. In theory, it should be the exact same. If I made a mistake here, of course, which does happen, that's 36.48 yards. And that I box in because that is answering an important. And you know what? Let's do this. I actually appreciate alternate solution. Let's do the alternate solution, right? Find angle B on large, right? Large triangle. So angle B is 180 minus 32 minus 49. So I'm going to take these two angles away from 180 to get me that big angle B there. That's 99 degrees. Very important to me. And I'm going to slow down a bit. Make sure you write that down. So I now have 99, which is the whole thing. That 99 cannot be equated to just x or just y. It's actually the whole thing, right? If you're using the whole angle, you need to use that whole side across from it, okay? So we're going to go sine of 99 over, I should start with my pair, right? I always told you that, right? Not that it matters, but let's start with sine of 49 over 79.2. And then I'm going to go sine of 99. And let's see if you're okay with this notation here. AC. You're not okay with ACs, right? So it's a bad combination to use. But I'm using, right, I'm trying to find A to C. So I'm going to use that there. So you cross multiply and divide. So side AC is 79.2 times sine of 99 divided by sine of 49. And I have to calculate that. Sine of 49, 103.65 yards. That's going from A to C, okay? So to find side Y, I would go AC minus side X, which I already found. I'm eating into the space for the bottom there, I apologize. So Y would be 103.65 minus 67.17. Okay. 36.48, just like we expected, right? So yes, everything, like it can be done in various ways as long as you make sure you keep things paired up correctly and you do it right. For example, if you went sine of 99 over 6717, like if you went right 99 and then just used x as the side across from it, that's a mistake, right? So I will give you the answers to this, and it's up to you if you want to try it. Okay, so you try if you want to do this on your, it'll be very beneficial. So side xp turns out to be 4,632.25 miles, and side py is going to be 5,696.90 miles. So if you want to give that one a try, let me zoom in. Make sure you update. If you haven't done this, you need to add this length here to your triangle, or else you can't do it, right? 7201 is the side there, YZ or ZY. So this is how you do triangles where there's partitions, right? And it results in two right triangles inside that oblique triangle. Make sure you remember your height. Like finding the height is a very quick way to find that missing triangle, the side for one of the triangles. That's actually one that they share, right? The height is usually shared between the two triangles that result from it. And once you're done copying this, you go to part 2. We're leaving part 1 behind. And so you can call, I called part 2 word problems. I put that on there as well, word problems. So it works out pretty nice that way. I had to rush it, the first booklet, to have it in time. And so here's the second one. Okay. So let's open that and start working through that. So I know that your grade 10 teachers did an amazing job at covering trig and showing you how it's done. And but I still will review some of the concepts. So you ready? So now that we've learned how to solve side and angles using sine cosine law, we can start solving for word problems. Okay. So in general, you should always draw a labeled diagram. This is important, right? Assign letters to each triangle, to each angle. Okay. If it seems that you're stuck, start solving for sides and move in, right? You slowly move in onto the unknown side or angle, because you will feel stuck from time to time. So just see, like, what can I do? Okay. And I find that students are discouraged because they're like, oh, I did it the long way. Don't worry about it, right? Like, just do it your way. If you get to the answer, then you're good. Show how you set up and solve for missing dimensions. Round final answers to 2 decimal places, including angles. Remember to check if your answer is reasonable, right? Just, if you get an error, you made a mistake. Or Mr. Dirksen made a mistake on the setting up the triangle, but most of the time, I will tell you to check your work, okay? So definitions, angle of elevation and angle of depression. So this is how I usually show this one. I just have a person standing, right, like that. And then I look at the eye level, and going out of that, I will use a ruler for that. I will go straight out horizontally. Your eye level, you imagine a dashed line that represents your eye level, okay? And it's a horizontal, right? Maybe just let's forget about eye level, just do the horizontal. I think that is really what I want to emphasize. It's a horizontal line, okay? And then I will use 2 different colors, but you don't have to. My angle of elevation is between a horizontal and the line looking up. Do you remember that? I hope so. And angle of depression is always between the horizontal and the line looking down. And usually when you're looking up, you're looking at something, right? The top of the tree, an airplane, kite, a mountain, a building, something up, right? I'm just going to have a bird there. That's as good as it gets for me. And if you're looking down, right, I will just have a bug crawling there, okay? So you're looking down, that's your angle of depression. So the angle that results here is the angle of elevation, okay? And the angle that results between the horizontal and the line looking down is the angle of depression. Very important concepts. I would be very surprised if you've never heard or seen this concept. Right, so angle of elevation, angle of depression. Okay. Supplementary angles are very important as well. You are going to need to be comfortable with, like if you have a scenario drawn like this, for example. Let's say this is the ground. This is a pole that's leaning, right? And it's telling you that this angle is 30. And you notice that the angle that they're giving you is outside the triangle, correct? You want it inside the triangle. So you should notice, right? You should realize, okay, this is 150, right? Because they both of them meet along the horizontal, and there is your 180, right? Supplementary angles whose sum is 180, okay? So the action happens along the bottom here. Yikes, smudged it a little bit. So make sure you're comfortable to bring stuff inside. That will be quite handy in a number of instances. Guy wires, I don't know if you know what guy wires are, but anybody know what guy wires are? It has come up in Trig. I know you've seen it. You're probably not paying attention. But guy wires are anything that supports a pole, right? So I don't know if you've walked down the sidewalk and there's a hydro pole, right? You know, these hydro poles that carry the power lines like that. And there's this wire that has like this yellow sleeve around it so you don't knock your head off, right? But this is a guy wire. Okay? It's a support. It's used to keep poles from leaning over, right? So obviously you can see that there will be a triangle formed between the guy wire, the pole, and the ground, right? So I just put it in there because I don't want to assume that you know what guy wires are. I don't want you to lose marks because you don't know what that is, okay? Okay, now that that's out of the way, we can do our first word problem here. So I'm going to start easy, and then we're going to start talking a bit more complicated, okay? So let's go to page 19. I will do this at the top. This one is easy, okay? I know you're going to be like, yeah, I know how to do it. So let's give you an easy one, then I'll give you one that's a bit more challenging, okay? Okay, a radio antenna supported by two wires on opposite sides. The wires are anchored. Anchored means like they're fastened to the ground, right? 60 meters apart. One wire has an angle of elevation of 62. Right, there's that angle of elevation, 62 degrees, while the other one has an angle of elevation of 75 degrees. And I will say that they're 60 meters apart along the bottom. So let's go ahead and draw this. We're going to sketch our scenario. Okay. So you have the ground, and we're assuming that the ground is perfectly horizontal. Okay. You always assume that. And this is your radio antenna. And right there's the antenna that's emitting the signal. And we know that two wires are attached to it and are supporting it. I will say this, okay? Let's write this down on the side here. Assumptions. There's my. One second. I had a piece of newsleaf that talked about the assumptions. Right here. Assumptions we're making, because you always make assumptions, okay? If it's not stated, right? We're assuming that the ground is flat, obviously. Triangle is not symmetric. Do not assume that it's symmetric unless there is a clear indication that it is, okay? Wires connect at the same height. Okay, all of these are assumptions that I'm making here. You don't have to write them down when you solve, but we are making assumptions. Okay. One wire is 62, the other one is 75. I'm going to call this wire 1 and this one wire 2. The corners on the outside, let's go A, B, and C. X, Y, Z, whatever you prefer. The tower makes a 90-degree with the ground. That is also an assumption we make, that unless they tell us that the tower is leaning, it's a perfectly 90-degree angle there. And you got to insert angle of elevation. We know it's between the horizontal and the line looking up. So one of them is 75 and the other one is 62. I'm going to put 75 here and 62 there. Don't worry about drawing it to scale, and just place it in there, but that we knew that angle of elevation would go there because it's between the horizontal and a line going up. Okay, so we've done that. B, determine the length of each wire. Okay, so we're going to go wire 1 first. I will find angle B first and foremost, right? 180. Hold on, do I need that? I'm missing something on my diagram, right? The 60 meters. That they're telling me that the wires are anchored 60 meters apart. Sorry about that. I'm rushing through this. Shouldn't be doing that, right? So we know that this is 60 meters from end to end. And that is why I'm looking to find angle B, because then I will have my pair. So angle B is 180 minus 75 minus 62. Okay? And that gives me 43 degrees. And so now I have a pair. Have pair now, right? It's important, so I'm going to use sine of 43 degrees over 60 meters, right? And then sine of, if I want to find wire 1, I need to use this angle right here. Okay? And that's wire 1. So wire 1 is 60 times sine of 62 divided by sine of 43. And if you calculate that, you get 77.68 meters. And so that would be the length of wire 1. You've clearly indicated which one you're solving, and there it is. Okay. Wire 2. I'm going to start with the same pair. Sine of 43 over 60 meters. Except for this time, I'm going to use 75 to find that one, right? So sine of 75 over W2. So 60 times sine of 75 over sine of 43. You calculate that, you get 84.98. Now, I need you to be specific with your labeling, okay? Like if you just go on and just solve things, I need to know exactly which one is which, right, on your diagram. Don't just leave me guessing there on which one you think it is, okay? And now we're going to calculate C. If you read C, calculate how far up the pole the wires are attached, right? Basically, find the height of triangle ABC. That's basically what you're being asked to solve. Because if you look at your diagram, right, how high up the pole are they attached to? They're asking for the height. So you have two options. You can use, sorry, I'm gonna go back up. You can go wire 1 times sine of 75, or you can go wire 2 times sine of 62. It's up to you which one you want to do. Okay, I will use W1 times sine of 75, and so that is 77.68 times sine of 75, and that is 75.03 meters. Okay, and there you have a full word problem. I'm just going to say this. We didn't find an angle here. I don't want you to forget how to do that, right? We didn't use cosine law, but I don't want you to forget how to do that. When I assign questions, you are going to come across cosine scenarios, okay? And look at the homework here, down here. So after today, I'm going to assign 2 priorities. This is priority 2. The one that's on the next page is going to be priority number 1. So if you just want some quick word problems that get you to practice, page 12 in the workbook. Okay? So I'll just show you, right? Law of sines and cosines word problems. There's just a bunch of word problems there. And guess what? The answer key is right next to it, fully worked out. So you know exactly, you kind of want to fold it and not look at it so that it doesn't give it away, right? So just try it and then solve it. Right? What are we at here? 124. So I told you it's going to be a bit information overload, but that's how it is sometimes, right? So I want you have lots of room and you can erase if you want. Just right here, just use this space right here to make a diagram. Read this. Would you be able to sketch a diagram? I don't care if it's completely wrong right now. All I care about is you trying, okay? So just give it a try. Read the question. Remember you got to remember the terminology, vocabulary used. So let's see. This is how, I mean, I've done a lot of these, right? So I kind of know already, but if I'm thinking something is flying up high, right? I'm thinking there's the ground kind of parallel to the top, right? So I would say this is just how I envision it, right? Hot air balloon, you can't laugh, right? Remember? there's the distance between that and the ground given to you right away, right? If this is the ground here, we know that this is 2,500 feet, right? Because it's flying that high above the ground, okay? So don't feel bad if you didn't get it, like at all. Like right now, it was just like, see cold turkey, if you had no example done before, how would you do it? So from up here, remember there's an angle of depression. Did you notice that? Right? You should right away be like, okay, if you're up there and there's an angle of depression, there's this imaginary horizontal line going along. Right? And so the first spot that is being spotted here is Forks, right? Where does the angle of depression go? It goes between the horizontal and the line of sight going to it. So the 34 would actually go right here. That whole thing here is 34 degrees. Yep. This is the wrong depression, guys. Some students would put the 34 here. That's not right. It's always between the horizontal and the line of sight going to the object you're interested in. So if that's something you learned just now, I'm very happy about it, right? Like if that's, I'm not happy if you're making mistakes, just like you learned, oh, okay, the 34 is, the angle of depression is always between a horizontal and another line, okay? Never a vertical line. Okay, and then spotting a different object, I'm going to use a ruler for this one. The artist Reed building. It's a smaller angle. Did you notice that? Okay, so this is, I'm just going to go there. That's the other building that's being spotted. And where does the 27 go? It actually goes right here. This is 27 right here. And you're like, what is the 34 and the 27? What are they mixing up there? Is there a possible way to right off the bat just get this little sliver here? Right? Take the 34, which is the whole thing, and subtract the 27 from it and get that right away. Why don't we do that right away? It may or may not be needed later on, but I'll figure out this angle, right? I'm going to go 34 minus 27, and that's 7 degrees, okay? So I'm going to go 7 degrees, this little sliver, because both angles are kind of overlapping, so I can just subtract. Okay, that's out of the way. I'm also going to do this here. I'm going to make that a dashed line and make it a 90, and that's the 2,500 there. Okay. And now you need a game plan. Because what is it asking? It's saying B, calculate the direct distance between Amanda and the Forks. So the first question being asked is, let's call this Amanda up here. I'm going to refer to it as letter A from now on, FR, right? So this is the first thing I want to find out, the direct distance between Amanda and the Forks. So let's go ahead and try that. So B, I'm going to calculate that right here. I'm going to draw out my scenario. I'm a big fan of that, okay? So you know this is 90, you know this is 2,500. And this is where chapter 2, do you remember that angles unit that you really loved? The passionate, like alternate interior, all of that, remember that one? Not, right? But there's something, focus on this 34. This line is parallel to this line. Oh no. Oh no. Right? Would you agree that, right, that horizontal line at the top is parallel to the ground? So what does the 34, what is it, what do we call that when we bring it in like this? Alternate interior. You don't even have to remember alternate interior. When you see that, you just bring it in here. So this angle comes in there, and it's 34 degrees. The 34 comes in here. So I know that this is 34. Do I have a pair? Yes, sir, right? Like I have a pair there. And I want to find this. This is my unknown, which I can easily do, right? So I'm going to go sine of 34 over 2500. And you might be seeing something else. I can tell that some of you were probably figuring out 34. There's a 90 up here as well. So if you went 90 minus 34 to get this one, and then found your way to here, you would also end up with 34 degrees, because this is 56 up here. Okay, so there are multiple ways of doing this. Okay, so sine of 90, which is this one, over the side that I'm interested in, cross multiply and divide. Sine of 90 is just 1, so it's just really just looking pretty there. And that 2500 divided by sine of, that's 4,000. Yeah, 4,470.73 feet. Boom, you're done. But the diagram would have probably been worth 2 marks. Coming up with this 34 here would have probably been 1 mark, so that's 3. And then solving probably another 2. So it's pretty heavy, right? There's a lot that had to go in here before you could do it. Okay. And I hope, I'm telling you this was a hard one, right? If you're thinking, yeah, it's a little bit too much going on, it is. It's not the easiest one that you will come across. Okay, so we got that figured out. So C, determine the distance between the 2 spots. C. So be careful here. I might use a different highlighter just to, but I'm going to call the 2 spots here, I'm going to call that side Y. That's what they're asking me to do, right? Solve for Y. And this is where you will have different ways of doing it. If time allows, I will do the alternate, but not necessarily. I will focus on this triangle here. Okay, so let's draw that out. And so what do we know? We know that this is what? Very important. 7, right? I should have probably waited to here, but I was kind of pretending to be a student. It's like, oh, I see that right away, boom, put it down, right? Like, I might not know if I'm going to use it, but I just did that right away because it is pretty easy to do. It's just a subtraction there. Yeah. Jeremy, did you have a question? Do you see I have a feeling some of you see this right triangle here. And yes, you are right. It is a right triangle. I found this here, which I know is 4,470.73. I really like a diagram before I start solving. Let's do this. You know this 34 here? It's technically not part of our triangle, but it's very much needed to get us going here. This is 34. So we can find this, right? Just go 180 minus 34. And that is 146. You know what? I'm not going to put it here because I'm looking at, I want that side, right? I'm just going to go 146 here and write it inside as well. Now it's inside my triangle. And I'm in, my journey is to find a pair because right now I still don't have a pair. So this angle right here, I'm going to go 180 minus the 146 I just found. minus the 7 degree that I found up there. Why don't we do that? 34 minus 27 is 7. That's how I got this. And then this one here gets me 27 degrees. I will also write that in. So now I have a pair to get started. So sine of 27 over 4,470.73 is equal to sine of, I want this side down here, which I'm going to call y here. So I need to use that angle up there and put that over y. And if you want to, do it differently, go for it, try it, and you will see that you come up with the exact same answer. And you might even find out that for you, that would be easier to do it a different way. And that is 1,212 feet. The distance between the two. And the problem is, if you would have, based on what I knew, if you would have gone with this big right triangle here and solved for the whole distance here, you still would have to find this one to subtract, right, and get y. So yes, it can be done, but I chose to do it this way. Is it raining? Okay. I'm gonna pause there because I'm gonna pause right there. I would like you to make sure you write down priority 1 at the bottom of this page. Follow me, please, because 1 to 5 I would really say only if you want to, because they're diagrams. You're just solving for missing sides. This is really what I would want you to do. On page 171 in the textbook, 8 to 14 are word problems that are like this one that I just did. The nice thing about the textbook is they give you diagrams, so it's most of the time. So you kind of have it a little bit easier, but that's okay. I want you to just focus now on solving based on what you see and depending on the situation. Because you don't have your textbooks with you, I'm going to just tell you to go to page 12 in the workbook and just work through those. And then at home, you take your textbook, yeah, up, okay. Yeah. And when you go home, do the textbook questions. But for now, I don't want to continue. So 15 minutes, try this, and then 5 minutes before the bell, you can stop and relax a little bit. Yeah. The video? 1 second.